In question 5, the diagram shows a major arc AB of a circle with center O and radius 6. Point C and D on OA and OB respectively are such that the line AB is a tangent at E to the arc CED of a smaller circle also with center O. Angle COD is equals to 1.8 radians. In part 1, we have to show that the radius of the arc CED is 3.73, correct to three significant figures. Now, as we have to show that the radius of the arc CED is 3.73, it means we have to show that this length is equal to 3.73. Now, OB has a length of 6, we already know this. And as this whole angle is 1.8 and this length is also 6 OA, so it means that this is an isosceles triangle. So when we make a line from O till E, this will be a right angle and this angle will divide in two, so this will become 0.9. Now, as we already have this angle, to find the length of OE, we can use adjacent over hypotenuse, which is cos. So we can write it as cos of 0.9 will be equals to OE upon the length of OB, which is 6. So OE will be equals to 6 multiplied by cos of 0.9. So this will become 6 into cos of 0.9, which is 3.7. So first writing 6 multiplied by cos of 0.9. So the length of OE will be equals to 3.729 centimeters. And as we have to give it to two decimal place or three significant figures, so the length of OE will write it as 3.73 centimeters. In part 2, we have to find the area of the shaded region. Now, we already have this angle 1.8 for the small sector. To find the angle of this bigger sector over here, so we know that the total angle is 2 pi. So we can write that in part 2, first of all, we can write that the angle COD will be equals to 360 minus the angle, or 2 pi minus 1.8 radians. Now, once we have this angle, the area of the sector, we can call it OAB. So the area of sector OAB, or the larger sector, is basically given by the formula half r squared theta. The radius for the bigger sector is given as 6 centimeters. So this will become half into 6 squared, and theta will be 2 pi minus 1.8 radians. So substituting this in the calculator, so this is 2 pi minus 1.8 and multiplying it by 36 and then dividing this by 2. So this will become 80.697 centimeters squared. So the area of the larger sector is 80.697 centimeters squared. Now finding the area of the smaller sector, so the area of sector, we can call that sector as ODC. So the area of sector ODC will be given by half into r squared. Now, we already have the length of the radius, which was 3.73. So this will become 1/2 into 3.73 whole squared multiplied by the angle, which was 1.8. So 3.73 whole squared and then multiplying, so 3.73 whole squared and multiplying this by 1.8 and dividing by 2. So this will become 12.52 centimeters squared. So the total area of the shaded region will be equals to, so the total area will be the area of the larger sector, which is 80.697 plus 12.52. Adding these two up, we'll get 12.52 plus 80.697. This will be 93.217. So this will be equals to 93.217. And as we have to give our answer to three significant figures, so the final answer will be 93.2 centimeters squared.